Hey folks, okay, now we get into the fun stuff. This is the part of the course that I really like. So at this point, we're getting into the idea of writing code. And in particular, now we're starting to look at writing functions that are going to write code for us. And we pass parameters to those functions saying, here's how I want you to customize the code that you write for me. So this can be extremely useful. So we're going to take a look at a couple of examples of where we might use something like this. And then we're going to start with a couple of really tiny toy examples to build things like this, and we'll gradually build up into something a little bit more interesting. So we want to have functions that are going to write code. We want to pass parameters to that writer function, if you like, or that builder function, telling it what kind of customizations to do in the code that it's creating. It builds and returns the function for us, and then we can, use some of our use applies and fun calls and things like that to run it eventually on whatever data it is that we have to run it on. So writing code that writes code is called metaprogramming, which is one of the things that I absolutely love. But the functions that are going to do this for us often get referred to as closures. The functions that write customized versions of other functions we'll refer to as closures for the time being. All right, so just in terms of an example, we'll talk about a couple of the more interesting, more complex examples, and then start writing with really tiny stuff, but we'll see how we go here. So let's suppose we're thinking along the lines of games, and we've got a whole slew of different AI characters in some game. And we decide that, okay, I'm going to have a function that controls what an AI character does at any point in the game. So, if it's cycling through, figuring out, maybe it runs through all of the AIs and figures out what they're going to do next. So it runs this function on each of the different AIs. In a case like that, then we've got, let's say we've got tons of different types of AI. We've got, depending on what your game style is, you've got all sorts of different factions and all sorts of different alignments and all sorts of different skill sets and all sorts of different equipment and abilities and other hoo-ha. So our generic function to figure out what an AI is supposed to do has to take all of that stuff into account. Am I dealing with this kind of a character? Am I dealing with that kind of a character? Does it have this trait? Does it have that trait? And so we wind up with this hugely complicated function that we have to run on every single AI. It's got to make all these decisions about these AIs over and over and over again. Suppose instead we had a little tiny custom function just created for that one character that already knew what their traits were and what their abilities were and what their mindset was and what their inclinations were. And so it only had to focus on the logic for that one character. So this means we have to create all of these different functions for all of these different characters, but it means when those run, we're running a fast one just for that character rather than running this big bloated generic one. So it takes extra time to generate the character because we have to generate the controlling function for that character. But after that, as the game goes on, the actual runtime is greatly reduced because you're just running these tiny custom functions instead of this great big bloated one. So this is the idea. Or maybe we think of web pages. Suppose we've got a huge array of we've got some application in it. It's got a huge collection of different display options that people can pick from, and all sorts of different ways that they can configure the data that they want to see that's related to their app. And so they go through and they pick a whole bunch of settings that they want to use as the way they see information. And the different subsets of information that they want to see and all this kind of thing. So maybe they don't change their settings too frequently. I could have one, when somebody wants to display their data, I could have this one big, again, complicated function that goes through all the possible settings and thinks about, okay, well, if it's a this choice, I need to do this, and then if it's a that choice, I need to consider that, and if it's this option and that setting, blah, 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 blah. Same idea. We've got this big, complicated, bloated function that has to take into account all of the different things that could be set and all of the different ways they could be grouped and arranged. Well, again, instead, suppose when somebody picked their settings, we generated a function based on those settings that would do the display based on those settings. So anytime they change their settings, we regenerate this function for their new configuration. But whenever they go to display their data, it runs this little tiny fast custom function instead of the great big bloated one. So again, you get extra delay when they change settings, but most of the time, you're getting much faster behavior and a much smaller function. But again, you've got one of these small custom functions for every individual user. So these are the kinds of scenarios where you might see something like this, where when when an AI is created or when their traits change, this control function for that AI gets regenerated, or when somebody changes their settings on whatever the application happens to be, their display function gets regenerated. But because these happen much less frequently than the functions themselves actually get used, the cost benefit works out in our favor. So this is the idea. Now, again, we want to start small. Doing something like that is going to be writing the code to write these little custom functions tends to be pretty complicated, especially when we start getting into these big scenarios where there's huge collections of settings and stuff to worry about. So we're going to start with a tiny example and work up. And so basically what we'll do is write one of these builder functions that takes just a parameter or two and uses a lambda to generate the function that it's going to create. So it's going to customize this little tiny lambda function that it then returns for the user to run whenever they want to. So we'll when the user is trying to use this thing, they're going to run our builder function, our writer function. They're going to store the function. It's going to create a function for them. We'll store that someplace and then run it whenever we want, using fun call, apply, something like that. So our first really super tiny one is just going to be something that we're going to return a function that prints a message for the user, but it's going to have their name embedded in it. So our construction function, our writer function, will take their name as a parameter, and it returns this function that prints messages with their name embedded. And again, this is very much a toy example, but it gives us an idea of it'll give us a look at just the core way to construct our builder function. So an example of using it would be something like this. So we'll say our builder function is called buildprint. So they call buildprint and give it a name, superme. It goes off and returns a function for them that they'll store in print. And whenever they want to run the print function, they just use fun call and print and whatever the message happens to be. And what this actually does is print the name that they originally provided and the message. Again, just an example to show the build print embedding something in a function that it creates for you. So we'll have a quick look at an implementation for this. So we'll have our build print, and again, this is going to return a function. It expects to get the username as a parameter. And what it returns is a function that takes the message as its parameter and prints that username and the message that it was passed. Right, so our lambda function just takes the message, it prints that original username and whatever message the lambda was passed. So again, the user will run this print function, or run build print rather, once to create a printer for superme, and it'll run it again to create a printer for someone else. So we're calling that builder function twice, and those should be def vars. Let me make a note of that so I actually go fix my slides in a moment. And so it'll call this function, returns a function that prints a message with superme embedded in it. We store it in a variable, call it again with someone else, store it in a variable, and then we'll try these out. So we call that first printing function and say wants to go home. And so that the function that's stored in that variable runs and executes superme wants to go home, right? It runs that format statement with the username superme and the message that they just passed. We run the same function on print2, pass it some other message, and again, it displays that embedded hidden username and whatever string they were just, or whatever text they were just passed as the actual text to display. So you get this kind of behavior where you can build and return a customized function that people can then use. Now, this build function should probably think about what error checking it needs to do. So maybe we decide that the username really ought to be a string. So buildprint should check if username is a string and build a function appropriately based on that. So maybe if they give something that isn't a string, we'll just use an empty string as the username. And if they give a valid string, then we'll use that as the username. So that's one thing that buildprint should probably do, is check that the username is valid and customize this lambda function a little bit based on whether the username originally supplied was valid or not. And the other thing it should probably do is this lambda function, maybe it should make sure that message is actually a string. So we should have something in here that says, okay, if message isn't a string, display some kind of an error message. Otherwise, display the regular format message. So maybe let's take a quick look at that. Let's see if we can, what did I call this? So a fancier version of buildprint. So this time buildprint itself is going to do some error checking on the username, and it's going to insert some error checking in the lambda function that it returns. So what we're going to do in buildprint is we're going to have a local variable that's going to be the name that we will actually use in the format statement. So if they gave a string for username, then that's what we'll store in real name. If they didn't, then we'll print an error message and just use nil. So remember that format returns nil if we're actually displaying to the screen. So this is going to say if username isn't a string, display this error message. The format returns nil, which gets stored in real name. So we'll use an empty string for the real name if they gave something invalid. So it gives them a warning that, oh, you're going to be getting a blank string essentially as, or at least it warns them that they gave an invalid username. So that's what's going to get used in the construction. So it does that error checking, remember what name it really wants to use, and then writes the lambda function. So lambda function, again, takes a message as its parameter. It checks if that's actually valid. And if it is valid, then it prints the message that they passed with that embedded username. So it goes through and it prints that real name, and it prints the message itself. And if the message that they used in the call to this lambda function wasn't valid, if it was an int or something like that, then instead we say, you gave me an invalid message, and they tell you what the message is, and they tell you what that stored real name was. So an invalid, you gave me an invalid message to send to whoever. Right. So again, we can create a fancier construction function, a fancier build function. So let's give that a quick try. How will we do this? Let's do this in the interpreter. So let's load buildprint, and hey, no syntax errors, yay! So let's try running this. So let's try a def var. So let's say, let's just use P1. So let's call buildprint and say at first I want to print messages for Bob. And for the other one, let's do another one here. I want to print messages for Fred. And maybe one more let's give it one of those error cases. Let's see if we broke it. So it tells me that I gave an invalid username. So now let's actually try using these things. So let's try a fun call on P1. So let's get it to print a message for Bob, and it's just going to be, I don't know, hello. All right, so it says hello for Bob. Or if we do a fun call on P2, and goodbye, and it says goodbye. And if we give it just a bunch of question marks for P3, again, remember it was using oh, we used a nil instead of an empty string. I should have returned an empty string for that. Okay, well, there's a correction. So in our build print, instead of sticking the result of the format into our real name, I should have stuck an empty string in there. All right. And let's try one more with a bad value for the message. And again, it tells me that you gave me an invalid message, the 12, for Bob. Right? So each of these constructed lambda functions is remembering who they're supposed to be talking to, and they're applying whatever message you give them. So this is the kind of idea that we're going to work with. All right, let's go back to our examples. So again, this is talking through the same sort of idea. Let's say we've got our builder function should check the parameters it's passed, but it needs to insert appropriate error checking in the function it creates, that lambda function. So another example here. Actually, I think I'm going to steal something like this to use for one of the labs, but we'll address that in another session. Time dilation calculator. So if you've got somebody at some place that's, you know, traveling at whatever speed they're at, somebody else traveling at super high speeds relative to our first person, then time is going to appear to pass differently for one than the other. So there's a formula we can use to calculate that, assuming I haven't messed up the formula. But let's try this out. Let's say we've got a friend who's traveling on a spacecraft at some fixed speed, and we're staying back on Earth, and we want a function that's going to compute the amount of time that's passed for us versus for them. So what we'll do is we'll call the function and tell it how much time has passed for us, and it'll tell us how much time has passed for them. But that function is going to be based on whatever speed they were traveling at originally. So we're going to have this builder function that says, hey, I've got this friend that's traveling at this speed relative to me. Write a function for me that tells me the relative passage of time for the two of us. So this is going to be our customization. So we'll call time builder and pass it the speed that they're traveling at in kilometers per second. And so we'll just store that. So it's going to go off and create the function for us, the time calculation function for us, and we'll store that in bobtime. And we call bobtime and say, okay, it's been 1,000 days for us. How long has it been for Bob? And it will go off and do the computation for us. So this means that the function that gets built needs to have error checking to make sure that this thing is actually a positive number. And the construction function, the builder function, needs to be able to check that the parameter we gave it was, again, a positive number. So we've got error checking to build into the two, and this is pretty much like the idea we were looking at in our printing example. We've just got something that's a little bit more complicated. And again, assuming I haven't messed up my formula here, but our time builder takes a speed, and if the speed was a real number and it was greater than 0, then we'll generate this time function, and the time, or our time calculation function. So this is a lambda function that expects one parameter, the time that passed back on Earth, and it's going to say, okay, well, if that time was a real positive real number, then we'll apply this formula to figure out and return how much time has passed for Bob. And if it wasn't a positive real number, then we'll just produce an error message. Right? So again, Oh, actually, maybe what we'll do is let's try one more time. If the time that was provided to the construction function was valid, we'll build one lambda function that says, here's how we calculate it, based on that valid speed that you gave me. Maybe if the original speed wasn't valid, we'll still return a function, right? We'll still return a lambda function, but this is basically just going to be a function that they can run that says, oops, somebody gave us an invalid speed back in the beginning, so I can't calculate the time for you. Right? So this is another possibility where, depending on the parameters that you gave, you actually build and return completely different functions. All right. So again, if we try out our error handling and we call build time and store it in a variable and try to run it, this is the case where it would have created that function that just automatically generates an error message. When somebody built me, they gave me an invalid speed. Or the other case where somebody calls build time but with a valid number, but then they call the function with an invalid time, then we get the appropriate error message from that. So again, the kinds of things that we're going to want to be able to consider when we start getting into writing these construction functions. All right, that's where I will leave this one for now.